agent, agent, multi-agent,
Anyone, please unmute yourself. Are you able to see the screen and audible?
Yes, sir.
Okay, thank you. Now, this is the fourth, we have completed fourth module, and this is the fourth, afterwards the fourth module, you have fifth module. In that, first you have to measure the force, torque, pressure, strain, and temperature. So they have kept 5 chapters in this module, 5 chapters: force, torque, pressure, temperature, and strain. First, come to the point. First, force measurement. First, what is the force? Force may be defined as the gravitational attraction between the masses. Gravitational attraction of the masses or between the masses. One thing. Say, you have 5 kg dead weight and 10 kg dead weight and 20 kg dead weight. All of you seen the dead weights are used for weighing groceries or some items. So you can easily lift 2 kg and easily lift 5 kg. Twenty kgs? No, it's little difficult. Suppose if you have very strong muscle and body, you can lift 20 kg, and otherwise it is difficult. So that is the moving downward direction. Say, remember, while lifting, the dead weight in a tendency to move in the downward direction. That is gravitational attraction. Gravitational attraction. You can lift 2 kg or 5 kg or 10 kg up to some time. Afterwards, you have to keep on the floor. So that is gravitational attraction. That is gravitational attraction. Say, usually the force are measured by using calibrated device. Calibrated device. That is the digital weighing machine, analytical balance, or platform scale. All of you seen in mandi or wholesale shops, they use the scale for weighing of 20 kgs of rice or 50 kgs of rice or the 100 kgs of grains using platform scale. In that scale, the measurement is done by using the mechanism beam balance. Beam balance. That's very, very important. Beam balance. When the beam moves in the upward direction, then applying the or removing the unknown weight on the platform, you can bring the beam in the normal condition. That is called beam balance. So that is the beam balance is the weight of the unknown magnitude you placed on the platform. That is the force. That is the force. Next, come to the point. The fundamental method of force measurement. So this is a very, very important. In the first question in fifth module is a fundamental method of force measurement. This fundamental method is classified into two. One is direct comparison, other one is indirect comparison. See, now we already discussed maximum measurement chapters, maximum measurement concepts. In that already you have a concept of what is a direct comparison, what is indirect comparison. You all belongs to mechanical engineering. Direct measurement, direct comparison, direct calibration, indirect calibration. Like that, you have lot of direct and indirect method of measurement. First, come to the point. What is a direct comparison? Direct comparison. Say, all of you gone to vegetable shop, or in Kannada we call it as sante. ನೋಡಿದಿರಲ್ಲ ಎಲ್ಲರೂ ಸಂತೆ. ಅಲ್ಲಿ ಹೇಗೆ ತರಕಾರಿ ತೂಕ ಮಾಡ್ತಾರೆ? There will be a two pan that is connected to a beam. In the center of the beam, there will be a needle, and above that needle, there will be a U type of ring. In that U ring, there will be a center point. When the needle comes to the center point, that is the actual weight of the unknown grocery or unknown vegetable. In the same way, the direct comparison is keep 1 kg dead weight in the left pan and the vegetable on the right pan by adding or removing the vegetable in the right pan bring the needle to read 0. That is called null balance. You may have a question in the competitive examination, that is, what is null balance? What is null balance? Say in case of beam balance measuring instrument, for that good example is analytical balance. Analytical balance. So that is used in chemistry laboratory and other laboratories. You already used analytical balance. So in that, what you have to do, keep the dead weight in the left hand and keep the unknown weight in the right side. Bring the beam to read 0. That is called null balance. That's also called as null balance technique. This is direct comparison. This is direct comparison. For that, good example is analytical balance. Analytical balance. That's good example for this is analytical balance. The indirect comparison. Say indirect, the name itself indicates indirect. That is, there will be two or more translation are present. Two or more translations are present. That is, for example, all of you say the electronic weighing machine or digital weighing machine. Nowadays, all the jewelry shops, all the provision shops, and many, and in the weigh bridge, they use the electronic weighing machine. In that, what will happen? There will be a platform. On that, you keep the weight. For example, the electronic weighing machine used in the provision shop. In that, what all the conversions takes place? That is, when you keep the unknown grocery or rice or any item on the platform, what will happen? Which exerts the force on the platform. The platform is connected with sensors. The sensors has strain gauges. Strain gauges. Due to the force, there will be change in the resistance that is converted into analogous signal. Again, that analogous signal is converted into voltage signal. That voltage signal is converted into digital signal. That digital signal is read from the display unit in terms of grams or kgs. So here you have two translations. Analogous signal is converted into analogous signal is converted into voltage signal. Voltage signal is converted into digital signal. Digital signal is displayed in the digital display in terms of kgs or grams. So here in indirect comparison, you have two or more.
ಸರ್ ಇನ್ನೊಂದಿಬ್ರು ಜಾಯ್ನ್ ಆಗ್ಬೇಕಂತ ಎಕ್ಸೆಪ್ಟ್
Same
ಮಾಡಕ್ಕೆ.
way, the measurement of resistance, measurement of voltage or measurement of current by using multimeter. There also you have two or more translations. That is the indirect comparison. So all
ಸರ್
of
ಇನ್ನ
you
2 ಮೆಂಬರ್ಸ್ ಜಾಯ್ನ್
understand?
ಆಗ್ಬೇಕಂತೆ.
Hello?
ಹಾ ಸರ್ ಜಾಯ್ನ್ ಆಗ್ಬೇಕಂತೆ, ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಬೇಕಂತೆ.
ಇಲ್ಲ, ಆಟೋ ಕೊಟ್ಟಿದ್ದೀನಲ್ಲಮ್ಮ, ಆಟೋ ಅಕ್ಸೆಪ್ಟೆನ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಹೇಳು, ಜಾಯ್ನ್ ಆಗಕ್ಕೆ ಹೇಳು.
ಓಕೆ ಸರ್.
ಪ್ರೀತಮ್ ಜಾಯ್ನ್ ಆದ್ರ? Once again, the fundamental method of force measurement is classified into two types. One is direct comparison, other one is indirect comparison. The direct comparison is the standard known magnitude is directly compared with the unknown magnitude. That is the direct comparison. For this, good example is analytical balance. Next, the indirect comparison. So indirect comparison, here you have two or more translation. That is the conversion from input to the output. So for example, a good example is electronic weighing machine. There, the force of the unknown magnitude is measured by using in terms of voltage signal. Here, what will happen if you keep unknown magnitude on the platform? So below the platform, there will be sensors. The sensors contains the strain gauges. That strain gauge, due to the application of the force on the strain gauge, there will be change in the resistance. That resistance is measured in terms of analogous signal. That analogous signal is converted into voltage signal. Voltage signal is converted into digital signal. That digital signal is measured in the digital display in terms of grams or kgs. So that is the direct comparison and indirect comparison. Please, all of you, write down the question. Please, all of you, write down the question. Without this question, there is no question paper at all. In the fifth module, very first question, write down what is force? What is force? Put a question mark. What is force? Put a question mark. Next, to write down. Explain briefly. Explain briefly. Fundamental. Explain briefly the fundamental method of force measurement. Fundamental method of force measurement. For this question, first you write down the definition. Force may be defined as a measure of gravitational attraction between masses. You have to write this definition. What is force? Force is the gravitational attraction between the masses. Force is the gravitational attraction of the masses. Next part of the question, for that answer is the fundamental method of measurement is classified into two. One is direct comparison. Other one is indirect comparison. For this, you write the explanation. Direct comparison is direct measurement. That is a beam balance using in analytical balance. Then the needle come to the zero reading. That is a null balance. For mechanical engineers, always use the word null balance. Don't write to zero. The needle coincides with zero. Like that, you don't write. You have to write the strong word null balance. Null balance. Next, come to the point, indirect comparison. Here, there will be two or more translations are present. For this indirect comparison, here the good example is electronic weighing machine used in the bridge, grocery shop, or in the jewelry shop. You might have seen the electronic weighing machine. Next, come to the point. This is the analytical balance. I told you, say In Kannada, in Sante, they are using the scale or takkadi. In Kannada, we call it as takkadi. So how they measure the vegetables? They are keeping the 1 kg or half kg dead weight in the left side, and the right side they keep vegetables. For example, onion or any vegetable. They keep the unknown weight of the vegetable in the right side. By removing or adding the vegetable, they bring the needle. All of you observe here. This is the needle. They bring the needle to read 0. Before measuring, you have to bring the needle to 0. That is called null balance. That is called null balance. Before weighing, before keeping the dead weight in the left pan or unknown groceries on the right pan, you have to bring the needle to read 0. This is called null balance. This is called null balance. All of you observe here. The needle coincides with the 0. If the needle oscillates between the divisions, maybe 10 on left side, 10 divisions on right side, then by adding the vegetable in the right pan, bring the needle to read null balance. See, all of you observe here, there will be a trapezoidal pointer is present in 3 points. In 3 points, all of you observe here, the triangle, the trapezoidal pointer looks like a triangle here in 3 points. See, all the 3 points are oscillating. See, in downward direction. W1 is the steel yard mass and W2 is the unknown force, which is coming in the downward as well as in the upward direction. That is the beam balance, analytical balance. All of you observe here. This is very, very important. Almost all the question paper, you have a question on analytical balance. Please, all of you, write down the question. Please, all of you, write down the question. Explain briefly. Explain briefly with neat sketch. Explain briefly with neat sketch. Analytical balance. Analytical balance. Put a question mark. List the applications. List the applications. Once again, the principle of operation of analytical balance. So all of you observe here, there will be 2 pans. In the diagram, you have W1 and W2. That may be in kgs or in grams. The pan is supported by trapezoidal points or triangular shape. You can observe here in all the 3 points, center and left side and right side, you have trapezoidal points on which the pans are supported. Here you have to keep the dead weight and here you have to keep unknown magnitude or unknown force. Bring the needle to read 0. That is the measurement. That is the measurement. This is the principle of operation of analytical balance. In the examination, you can explain with your own words. No need to reproduce the same explanation you have in the textbook or in the explanation. This is also called as moment comparison. The principle of moment comparison. That is nothing but the oscillation of left side and right side. Bring the oscillation of right side and right side pans to standstill condition. Then see the needle which coincides with the zero, reading zero, that is called null balance. The adjustment or comparing the left with the right, that is called movement comparison. And one more word you have to use, that is symmetry. Symmetry. One, the beam come to the 180 degrees, that is called symmetry. Beam balance come to the position symmetry, that is the measurement. And the analytical balance, or the balance which is used in chemistry laboratory and physics laboratory, that is the analytical balance. So already you have experience of weighing chemicals in the chemistry laboratory, that is analytical balance. Next, come to the point, very, very important. Almost all the question paper, you have this question, platform scale or multiple lever system, which is used in Kannada we call it as mandi. ಎಲ್ಲರೂ ನೋಡಿದಿರಲ್ಲ ಮಂಡಿ, APMC ಯಾರ್ಡಲ್ಲಿ ಮಂಡಿಗಳಿದಾವಲ್ಲ, ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರಲ್ಲ weighing machine. There will be 4 wheels are present, so they can move this platform scale one place to the other place. Here the beam balance is the measurement. Beam balance is the measurement. Beam balance is the measurement. Platform scale. See, in the top you have a beam. All of you observe here. You have a beam. Here you have the WP, the weight, counterpoise. It is called counterpoise. P-O-I-S-E. This counterpoise, this is the pointer which moves from 0 reading to, in that graduation you may have 10 or 20. That pointer indicates 1 kg. If the pointer moves to number 1 position, that indicates 1 kg. If the pointer moves the 5th point, that indicates 5 kgs. That is pointer. And WS, counterpoise. WS, counterpoise. Here the manufacturer of the scale provide the dead weight of 5 kgs, 10 kgs, 20 kgs, 50 kgs, 100 kgs. That dead weight you have to place it in the one end of the beam. All of you seen that type of weight that is placed in the hook provided in the beam. If you place a 10 kg here and the pointer moves 4th division, that indicates 10 plus 4, 14 kgs. 10 plus 4, 14 kgs. Suppose if you keep 50 kgs here and the pointer moves 1 division, then it is the weight is 51 kgs. Like this, the weight can be measured using platform scale. So you have a small derivation, that is force equal to tension T into radial distance R. F equal to T into R. Force equal to T into R. That is, the force can be measured by the application of the weight of this counterpoise weight and the needle. Counterpoise moving in the right side, the coinciding division. When the beam moves in the upward direction, that is the weight of the unknown grocery placed on the platform. All of you observe here, this is the platform. Once again, what all the things present in multiple lever system or platform scale. Observe here the adjustable counterpoise. Remember, say before doing anything on using platform scale, by adjusting the counterpoise, the ring, the rod which has the threads on that, you have a nut. By turning the nut clockwise and or anti-clockwise direction, bring the beam to read 0. That is, it should come to the standstill position in the center. Standstill position in the center. And this beam oscillates upward and downward direction. Oscillates upward direction. Upward and backward direction. And the one end of this beam is connected with the trapezoidal pointer, and the same which is connected to the platform with the same type of trapezoidal or triangular pointer which exerts the pressure on the platform. That is the tension T. That is the tension T. Then anywhere platform you have a doubt in your mind that, say, if you keep the weight on platform left side or right side or center or anywhere in the platform, you get accurate measurement. That is the advantage of using multiple lever system or platform scale. Then coming to the point, what are the things present here? Adjustable counterpoise, which is used to bring the beam to read 0 or null balance, and the pointer which reads the extra weight. If it is 10 plus 4, 14 kgs. If the pointer coincides with the fourth division, that indicates the 14 kg. So then the beam oscillates up and down, bring it to the center point. That is the weight. And here all of you observe here W, W1, W2. See, this is nothing but if you keep the grocery bag or rice bag or anything on the platform, anywhere on the platform, you get accurate measurement. You get accurate measurement. So if you keep the unknown weight W on the platform, which exerts the pressure on the lever, all of you observe here, one more lever is present. One end is fixed, other one is movable. That is, moves in upward and downward direction, exerts the pressure on the main lever. All of you observe here, this point of the trapezoidal exerts the pressure on the main platform. This is it connected to the tension rod T, which pulls down the beam in the downward direction. Due to that, the beam oscillates in upward and downward direction. All of you observe here up to F, letter F, A, B, C, D, E, F. That's very, very important. You have a small derivation on platform scale or multiple lever system in the examination. So this is a very, very important. Mark it, very, very important. 100% guarantee this time you have in the examination. Please, all of you, write down the question. Write down the question. Explain briefly. Explain briefly with the neat sketch. With neat sketch, multiple lever system, or platform scale. Put a question mark. question mark, list the applications and limitations. List the applications and limitations. Now I stop at this stage, and all of you write your name and USN in the chat box. Write your name and USN in the chat box. Who is the register number 43? 19ME 43. All of you unmute yourself. Akshit R. Answer roll call. Or Pritam.
Present, sir.
Present, sir.
Rahul N. Vedavyas.
Present, sir. Present, sir.
Kavish. Nitin GS. Pawan H.
Present, sir.
Pawan MC. Pawan MC.
Sir, name.
Okay. Pawan MC. Pratik JN. Pratik.
Sir, Nitin
Nitin GS. Okay. Pratik.
Hello. Nitin LM.
Present, sir.
Nitin
Prithvi.
LM.
Sir, present, sir.
Rakshit R.
Present, sir. Present, sir.
Sumuk Raj.
Yes, sir.
Vinayak.
Present, sir.
Yashwant.
Yes, sir.
Who is the USN number 43?
Hello. Nitin LM. Present, sir. Nitin
43
LM.
Nitin na?
Hello.
42 allama, 43.
Nitin
Nitin GS 42
Nitin
ತಾನೆ?
LM. 42, sir.
42 ಬಂದಿದೆ.
Nitin LM.
43
Nitin
ಯಾರು?
LM.
Nitin GS 42, sir.
43
Nitin LM.
ನಿತಿನ್ ಎಲ್ಲಮ್ಮ.
Nitin LM.
ಅವನಿಗೆ
sir.
ಹೇಳ ಹೆಸರು ಟೈಪ್ ಹೊಡಿಯಕ್ಕೆ.
Yes, sir.
ಹಾ. Okay. Now
What, sir?
I stop at this stage and I will continue in the next class.
Sir, Shashank HS, sir.
Huh?
Shashank HS, sir.
Yes. Okay.